our laboratory and our scientific project. Now we are working on innovative technical means providing more objective representation of geomagnetic field, its variations and their consequences. In 2009 we have developed the pioneer magnetometric geoestimation system based on anisotropic magnetoresistant effect. It was successfully applied in a number of educational and healthcare organizations, and it was also used for gathering medical statistics. In 2011, we have developed and successfully introduced the brand new conception. This conception is concerned with super-multisensory trigonometric nature of geoestimation system. We suppose the super-multisensory system as a system with more than 128 sensors. And this amount can be increased for several tens of thousands without any changes of system architecture. In 2012, the suggested term geomagnetic pseudostorm allowed many scientists and specialists to take a principally new look at the nature and pose characteristics of geomagnetic. At the same time, we have developed the software named Geomagnetic version 1. This application provides a calculation of geomagnetic field and pseudostorm parameters. Also, it much clears the parameters of geomagnetic field and pseudostorms for non-specialists. We think this fact is very important for the science popularization. In 2013, we have studied metrological characteristics of the experimental sample of the model GIMS 1T. The research proved that this model is 48% more preciously and 2 times cheaper than all the known analyses. In 2014, we have extremely increased the functionality of GIMS 1T. It was integrated with soft and hardware named Array Analyzer. Also, we have developed the test web service on the basis of Google Maps technology. Now, we are working on integrating all the mentioned developments to the unique multifunctional project, GIMS Earth. As a result, we will provide for non-specialists an opportunity to observe geomagnetic field in real-time mode, to study, analyze, forecast, and make the appropriate conclusions. We suppose that GIMS Earth project is a logical evolution of all the known geoinformation. So, what is GIMS Earth project and who is it for?
In modern world, specialists in many spheres pay great attention to the analysis of external geomagnetic variations. It is necessary to compare geomagnetic variations parameters with their influence on existence and progress of objects and systems of various origin types. No less important to analyze all the gained results and to identify their characteristics, regularities. Correlation between volcanic and seismic activities is well known in geology. Besides, geomagnetic variations strongly influence on various forms of life, complicated technical objects and systems, especially human beings. As a result, the exposed systems are forced to exist in unstable, insecure or stress mode.
If the Earth was alone in space, its magnetic field would be like an ordinary magnet. But, by many reasons, and first of all because of the solar wind, the Earth magnetosphere has a complicated form and structure. Here you can see its main areas. Programming formalization of mathematical provision, which is known as Gaussian, allows to observe a scheme of geomagnetic field distribution in the Earth or near Earth space as a set of geomagnetic isolines. Next, we extended the theory of data representation as isolines and introduced the term isosurface and isoline specs. Here, the isoline spec is a way of visualization of geomagnetic field force characteristic in space area which is limited by coaxial geomagnetic isolines. These isolines lay in parallel planes and show vector field distribution in three-dimensional space.
The next question was how the geomagnetic field anisotropy can influence on moving objects. It is obvious that while moving with low speed for short distances, that influence is insignificant. But what if the biological or technical object is moving in the anisotropic magnetic field 4,000 kilometers with a speed more than 1,000 kilometers per hour. How much is the influence force of a quick change of a magnetic environment or the navigation mechanisms, human organism in general and central nervous system in particular? To answer this question, we introduce the term geomagnetic pseudostorm. We suppose it as a geomagnetic field power action to the object in object existence area within undisturbed anisotropic geomagnetic field in condition of non-zero angular or linear speed of the object. The next research showed that amplitude and frequency characteristics of geomagnetic pseudostorm are bigger than same parameters of natural geomagnetic variation in tens and hundreds times. Application of geomagnetic pseudostorm term in a number of research proved its importance and relevance. As a result, we faced the necessity of defining the main parameters of this effect. Also, we have suggested mathematical expressions for their numerical estimation. The term acclimatization or temporary discomfort in jumping change of location can be explained from the geomagnetic pseudostorm point of view. So, ask yourself, what is the influence to the human organism from the change of the artificial time zones, and what is the influence of real multi-time change of the magnetic environment?
The situation is getting harder with a speed about 10,000 km per hour and continuous object movement redirection in space. The calculation proves that in this case geomagnetic pseudostorm parameters can exceed the normal values 4,000 times. It's known that when the object speed value gets 10,000 km per hour, the critical value of geomagnetic induction vector gradient can cause the failure of expensive equipment on board of Hubble Space Telescope.
To find out what is the effect of a geomagnetic pseudostorm on the Earth's surface, we took a trip to the highest building in the world. There we have studied parameters of geomagnetic pseudostorm in the quickest elevator in the world. Here are our results.
So, we can calculate and analyze geomagnetic pseudostorm parameters, but it's too simple to be true. In fact, the problem is that the true geomagnetic pseudostorm scheme is a superposition of magnetic field of magnetosphere and magnetic properties of the rocks. And the magnetic properties of the rocks have very complicated or even random distribution. It's impossible to describe it mathematically. We need something different. This approach must provide with an appropriate accuracy registration and visualization of geomagnetic field parameters on Earth and near Earth space. Here we introduce a paradigm of multi-sensor geoinformation magnetometric system. We suppose the multi-sensor geoinformation magnetometric system as locally or globally distributed sensor telemetric self-organizing system. This system transmits data to data processing center. This center in turn provides analysis and visualization of data and also calculates geomagnetic pseudostorm parameters.
These are contemporary world magnetic observatories. It's obvious that these constructions are not upgraded often. This is a reason of necessity of principally new technologies which provide geomagnetic field parameters registration in real-time mode. As a result, we have developed experimental sample of GIMS 1T hardware. It's based on anisotropic magnetoresistive effect. Metrological characteristics research of this sample provide that these characteristics are better than the same characteristics of analogs for more than 40%, and the cost is 3 times cheaper. Also, we extremely increased the functionality and processing modes of hardware. So, we provided a possibility to draw the maps of geomagnetic anomalies similar to this one. As a result, it's available to analyze real geomagnetic pseudostorm which take place while object moving on the Earthscape. It's especially concerns with high-speed vehicles.
So, there is an obvious conclusion. The quicker and closer to Earthscape we are moving, the greater geomagnetic pseudostorm effect is, and the harder its consequences. The effective solution to share this data is Gale information system of any type. One of the key developer tools here are the cartographic web services, and the most popular of them, Google Maps API. We used these web services to program some web scripts for geodata operation, from map rendering to calculation of undisturbed geomagnetic field parameters. This calculation can be performed for both single point and multiple points within the road. So, our web application allows a user to load the map, to pick up the point on the map, and to calculate parameters of geomagnetic field for this point in real-time mode.
Also, we have developed the programming application Array Analyzer. This application provides the total analysis of information signal in both amplitude and frequency areas. Also, in this application we have developed for the first time the prism function, which allows to define and analyze these harmonic selections of information signal. So, this was a brief description of GIMS project. If you have any questions, please welcome.